Looking at number 8, I have a large school with 30% are female, 80% are male, 8% of 6 foot tall for the girls, 25% more than 6 foot tall, and I want a tree diagram. So I'm picking a person at the beginning, and there are 2 things that could happen for this scenario. So this is saying for this scenario, 30% are going to qualify as a girl, and 70% will be put in the category of boy. From here, though, we know a little bit more. Once I know that I'm looking at a girl, then there are 2 things that could happen. Either this person is over 6 feet tall, or they're not. I guess I should have put under 6 foot tall. That's more efficient. We know this happens 8% of the time, which means the remaining 92% of the time they're not over 6 feet. We can make the same distinction for the boys, but now the probabilities have changed. So I still have the same 2 possible outcomes for the boys. We have 25% are more than 6 feet tall, leaving 75% of them to be under 6 foot. So we got our tree diagram showing all of our outcomes. And I know 2 boys are selected at random. What is the probability that they are both more than 6 feet tall? So, sorry, I was processing something. So I have to end up with somebody more than 6 feet tall 2 different times. I probably should have done this before I just started walking through it with you so I'd have some time to process. My apologies. So, I'm reading into this too much. All I want to know is that I already know that it's a boy. So you can essentially, sorry, this is poorly stated. I know I have 2 boys at the beginning. So I don't have to worry about, I just select a student at random. In this probability, there's no chance of being a girl. I know that I have boys. So if I know that I have a boy, I want the probability that the first person is over 6 feet tall. And I also want to multiply that by the probability that the second person is 6 feet tall, because we're using the multiplication rule because you're selecting 2 people here. So you're just going to take 0.25 to the second power. I'm sorry for overcomplicating that. So 0.25 times 0.25, so 0.0625, or 16th. So now part C was what I was initially thinking, because you have a student selected at random. So now it can be a girl or a boy at the beginning. I want the probability is more than 6 foot tall. So to find the probability that somebody is over 6 feet, there are 2 ways that could happen. It could be that a girl is over 6 feet. That's supposed to be 6 feet. Or the probability that a boy is over 6 feet. We are saying these are mutually exclusive because for this problem, we are not having anybody identifying as both or neither, so we're just going to go ahead and leave it as summing those 2 mutually exclusive events. So if I want the probability that a girl is also over 6 feet tall, we have to first select the girl and then multiply the probability that she's over 6 feet tall. Same thing for the boy. First, I have to end up picking a boy 70% of the time, and then multiply by the probability that that person is over 6 feet tall. So if I multiply out those probabilities, I'm getting 0.119. So those are we're considering the 2 ways to end up over 6 feet tall for this problem. So then for part D, 3 boys are selected at random. So I'm back to saying I've only selected boys. If 3 boys are selected at random, what's the probability that at least one of them is more than 6 feet tall? Because what you could get is none of them are over 6 feet tall, maybe one of them, but I don't know which one. Maybe it was the 3rd boy I chose. Maybe it was the 2nd. Maybe 2 of them are over 6 feet tall, but you have to consider the ways that 2 of them could happen. Or maybe all 3 of them are over 6 feet tall. If I want at least one of them to be more than 6 feet tall, those are these outcomes here. This has at least one of them over 6 foot. So it's everything except none of them. So I'm going to use the complement. This is 1. Sorry, I got distracted. This is 1 minus the probability that I got 3 under 6 feet tall individuals, or boys, sorry. Man, I can't write today. So I'm going to do the complement of that. That would be, I already know I've selected a boy, so the first person has a 75% chance of being under 6 feet. So it is the third and the second. So 1 minus 0.75 to the third power, which is about 0.578. So then part E, 4 students are selected. Now it's just students because we have to consider male, female in this point. What's the probability that they are all boys? So I don't actually care about their height in this problem. I want the probability that the first person is a boy, the second person is a boy, the third person, the fourth person. It's 0.7 to the 8th power. That's not the number 8, that's the number 4 to the 4th power. So I'm getting 0.2401. So then for part F, again, for students, I want the probability that at least one is a boy. The only way to have at least one boy is to not have all girls. So I'm going to take the complement of finding the probability that all 4 are girls. So for this, I'm going to have 0.3 for the first girl, 0.3 for the second, 0.3 for the third. I'm going to do 1 minus 0.3 to the 4th power. So we got a really high chance, 0.9919, of having at least one boy selected. Part G, I want to know if the events are going to be independent. So the student is a boy, the student is being more than 6 feet tall. So what I'm going to do is I'm going to compare the probability of being, that's not the notation I've been using, my apologies, being 6 foot tall, given you know you have a boy, and I'm going to compare it to just the standalone probability of being 6 feet tall. So if I already know that I'm looking at a boy, so we're looking at just the boys in this case, girls don't exist for this problem, I know that I have a 25% chance of looking at a boy who is 6 feet tall. But if I just want the probability of being 6 feet tall, you can possibly have girls who are over 6 feet tall. That's actually the probability that we came up here with part C. So I'm not going to recalculate that. The important thing is to note, these are not equal to each other. If they are not equal, then you say they are not independent. Knowing that you had selected a boy increases the probability that you are looking at somebody over 6 feet tall.